With the James Webb Space Telescope sending glorious photos of the cosmos, scientists and researchers are taking the findings and trying to piece together what newfound space structures are made of, how they form, and what it means for other structures in the future. So today, here at Unexplained Mysteries, we'll be taking a look at 3 amazing discoveries. Invisible black hole. An invisible black hole has been found just outside the Milky Way galaxy. For the first time ever, a black hole has been detected outside of the borders of the Milky Way galaxy. It's a small inactive black hole that seems to have been hiding in plain sight. It's located in a satellite galaxy called the Large Magellanic Cloud, which is a close neighbor of the Milky Way. Part of what makes this black hole discovery a big deal is that it could help scientists discover more black holes like it, as well as give a better understanding of how black holes are formed. Black holes are definitely deceptive beings. Their enormous density creates an extreme gravitational field that stops even light from gaining enough velocity to escape. They are hidden by the darkness with no light shining that we can detect. They deviate from this darkness when they are actively consuming space material. The process is quite chaotic and causes X-ray radiation to form around the margins of the black hole. When black holes are inactive, they are pretty much invisible, and the way they are best detected in this phase is the intense amount of gravity, but only if you know how to search. When a stellar mass black hole, produced by the gravitational collapse of a star, is in a binary system with another star, the movement of the orbit of its partner moving around what looks like empty space is a possible indication of a black hole being present. That being said, not all empty spaces are black holes. This can make it tricky for scientists to call their findings definite. This particular team of researchers was composed of astronomer Thomas Schenne of Amsterdam University in the Netherlands, Karim El-Badri of the Harvard and Smithsonian Center for Astrophysics, and Julia Bodensteiner of the European Southern Observatory. They have been meticulously debunking black hole discovery claims because the evidence has to be undisputable. For the last 2 years, this careful team has zeroed in their focus on the Tarantula Nebula in the Large Magellanic Cloud. This nebula is known for being a star nursery. Young massive stars call it home. Around 1,000 of these baby stars were studied to see if the scientists could observe a wobble that would indicate a binary orbit. The binary that helped discover the black hole is believed to be one of many that can be researched to discover the patterns of black holes. James Webb Telescope. James Webb Telescope peers through dust for an unprecedented look at a black hole. If you have been following any of the news surrounding the James Webb Space Telescope, your eyes have probably gazed upon the breathtaking photos being released by NASA. Notably, Webb's near-infrared spectrometer was trained on the supermassive black hole of Stephan's quintet. Quintet can be viewed in one of the first 5 full-color Webb images that were released on July 12. The photo is of 5 galaxies that are neighbors with each other, and the 5th one is much closer to the Earth than the others. One of the ways the chemical makeup of space material can be determined is through light passes. Since James Webb's spectrometer breaks light into constituent wavelengths and different elements absorb light at determined wavelengths, the infrared spectrometer gathered a light spectrum from the supermassive black hole, even though it is surrounded by stardust. The wavelengths that Webb used to view the supermassive black hole have never been observed. The result is they correspond to atomic hydrogen, molecular hydrogen, or 2 hydrogen atoms bound together and electrically charged iron ions in the gas surrounding the black hole. Because of these findings, scientists can map the gas structure being consumed by the black hole as well as any gases being excreted. Mighty streams of radiation are created by the extreme compression of gas and dust spiraling around the black hole. The near-infrared spectrometer is a very important apparatus for comprehending the chemical makeup of far-off objects. Scientists can use it to study stars, galaxies, and planets as well as black holes. Unique triple star system. A unique triple star system might have swallowed a 4th star. NASA's Transiting Exoplanet Survey satellite detected a triple star system known as TIC 4707. It's believed that up to 10% of star systems in the universe are triple star systems, according to NASA. They are really not an oddity. What makes this triple star system of particular interest is that it is unique from any previously discovered triple star system. This trio of stars is closer together and more massive than any other known triple star system. It's speculated that these three stars had a fourth star in their orbit at one point, but it was swallowed by one of its fellow stars. There is a hierarchical structure to this triple star system. A pair of binary stars moves in a circular motion in the middle of the system, and the third star orbits around them. The binary stars at the center of this triple star system together have a mass of about 12 times that of the Sun. They take a little more than a day to orbit around each other. The larger outside star is about 16 times more massive than the Sun and revolves around the pair once every 52 days. This is an impressive speed considering their size. A scientist studying the Transiting Exoplanet Survey satellite database was the original finder of the star system. It drew the attention of the amateur astronomer with its high luminosity. This is common when three bright stars are together. When researchers assessed the data, it was realized that this was a triple star system when they learned how large the stars are. The team of scientists put their efforts into figuring out how the atypical system might have formed. Three possible theories about the formation of the trio of stars in TIC 47071037 are on the table right now. The first and least likely to be true is that the outer star formed before the inner stars. This is debunked by the knowledge that the larger star would have absorbed any gases that would be the materials for the smaller stars to be born from. The second idea about how the triple star system was formed is that they all formed independently of each other and then came together through gravitational attraction. However, if this was the case, it's more logical that the larger star would be in the center. The third explanation is that there were two binary systems, the same one we can still see now, and a second one that orbited the first. At some point, the two outer stars merged, and that explains the extreme mass of the outer star we see today. After running the scenarios on a simulator, the team agrees that this theory is the most plausible. Scientists are looking for other massive star systems to see how common they are in the universe. As we continue to explore, discover, and learn, we are creating a thrilling and dynamic database of information that will continue to serve us long into the future when it comes to the universe and its many mysteries. But what do you make of these discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.